Thank you, thank you. Let's figure this out. Thank you everyone for attending this session, and I would like everyone to make a huge round of applause for all the organizations, because I know how it's hard to have a conference like this. So can we have a huge round of applause for all the organizers of RootCon? All right, so today I'm going to talk about how to have visibility and security of CI/CD ecosystem. So whoever has worked as a software organization or a product-based organization is aware that CI/CD is the only way of delivering the software in today's time. So it's important and imperative for all of us to have a look at how the software is getting built. So I was supposed to start with my introduction, but he did a pretty good job in that. So I'm working as a senior manager, application security assurance with Netscope. I speak at multiple information security conferences. I'm also OS Pune chapter lead and a private OSCP. So this is the agenda for today. First, I'm going to set the context that why I'm having this talk, what's the content and what's the need of it. What is the attack surface associated around the CI/CD ecosystem itself? What is the methodology which I have used personally in my organization and had worked for us? There were definitely some learnings, some things worked, some things didn't. So I'm going to share that. And then I'm going to introduce my open source project, CICDGuard, which is built around idea of securing the CI/CD platforms. We are going to deep dive into the architecture and the workflow of that. And then we are going to have a demo and what's the way forward for this project and the topic. So the context, like I said, whoever has worked in a product-based organization will know that that there is a bunch of source code of the developers which is stored in a central location, typically called SCM, source code management. And then we have a solution which converts that source code into a binary format, and then which is again stored in a central location, mostly called registry. And then we have a solution which converts or deploy those registries or artifactories into a working infrastructure. So that's how a typical software as a service provider organization works. It's an oversimplified version of the CI/CD ecosystem. And the things I mentioned in this slide, all of that come under the security in CI/CD, as we all know it. That integration of the security controls in the each phases of the CI/CD platforms. Everyone who has been into application security will know that it's been going on for some years now. It's a great topic, but today I'm going to speak about a related topic of that, which is security of CI/CD. This is not about how we are integrating the security controls within the CI/CD pipeline. It's about whatever builds, whatever component is making your CI/CD platforms, how do we secure those building blocks? And as with any ecosystem in the world, even if we have the compromise of one single unit, one single piece, one single smallest component of the CI/CD ecosystem, it impacts the overall system in the platforms. And I'm going to share that more about in our attack surface scenarios. Part of the problem which I have observed in many organizations is that it's not just the security part of the CI/CD, it's about the visibility part as well. So I just want to ask that how many of us are aware here that which kind of GitHub actions in your organization are getting used? Even if we have that count, how do we know that which version or which third-party GitHub actions you are using in your organizations? Or for example, how many Jenkins instances you have in your organization? Even if you have those information, do we have the visibility that how many jobs are running on those multiple Jenkins servers in our system? So it's the security always starts with the visibility part, with being aware of the entire system, that which all pieces of the software or which all pieces of the platforms you are using within your organization, and then how we take steps towards making sure that those pieces or those individual things are secure so that it doesn't impact the overall software delivery. So we have all heard of software supply chain security, where how a single piece, how a single supply chain can lead to compromise of the attack, of the overall attack, overall software attack system. So this is the attack surface I want to speak a bit about. So for example, you have a Jenkins server which is processing or which is responsible for building a binary which you are in turn deploying to your client environment. It's an absolutely critical piece because whatever is going to the customer environment is always gets scrutinized more from the security perspective. And in that scenario, if your Jenkins control or console is compromised, which will essentially mean that binary which you are in turn giving to your customer will be compromised. So it's about, oops, I think screen didn't like it much. Yeah, now it's back. So it's about how a single Jenkins instance in the overall platform is leading to a very critical piece just because some default credentials or something was enabled. It's not about the vulnerability itself, it's about how a single vulnerability, how a very trivial vulnerability can lead to a big impact to the overall business in the organization. The second piece is GitHub Action, which in the GitHub Action there has been a research about the vulnerabilities where attackers was able to perform the crypto mining using the private runners of the organization. So for those who are not aware, in GitHub we have two ways to run our action. The first is that we run the GitHub runners, which is basically servers hosted by GitHub, and then we have an option where runner we can host by ourselves and then run it. So what used to happen is a third-party action, which is code of someone else, is running in the server owned by the organization. So using that method, attackers was able to do the crypto mining. And it's the other way around as well, that where you are running your personal, your IP code, intellectual property code into the GitHub Action runner. So in that scenario, technically GitHub has the access to your code, and which will essentially can lead to the IT theft and all that, which is the third example I have put that, for example, if your GitHub, if any one user or developer account is compromised with the social engineering of the GitHub, then how it's going to essentially lead to the IP theft, which is going to impact the organization itself. Last example is, which will applicable to almost all the organizations. We have SSO in our environment, so one user is present in multiple platforms. It will be JFrog, it will be GitHub, it will be your Workday, so on and so forth. So if that user is compromised in one of the platform, how it's going to impact the other platform. So for example, if someone is able to compromise it by the JFrog, then essentially that attacker will have access to the to all the platforms for which the user is SSO is enabled. So this is the overall attack surface. Long story short, CICD is the only way of delivering software as of today because of the business reason. And as of today, more than ever, all the CICD platforms have access to the critical data. They are processing it, they are storing it, they are reading it. They have access to all the information, all the sensitive information of the organization. So like I said at the start of the session, securing all the pieces of the platform is imperative and critical for all the organizations as of today. So this is the attack surface, but how do we handle it? How do we approach it? So I call it a three-step process, three-step methodology. The first part of that is focus on making the software robust and secure by itself. Within this step, there are two ways to look at it. The first way is being a software provider. The second phase is being the software consumer. Every organization or every individual operate in both ways most of the time. And what I mean by that is, if you are a software provider, you are selling software to other people. This is where the security in CI/CD will come into the picture. And as an industry, we are doing good in that. We are making sure that whatever software we are selling to our customers, we are doing our best effort to secure it. I think it's the second part where as an industry we have the scope to work out. Whenever we are consuming any software, can we look at that software as we are building it and make sure that we are working with the software provider to make sure that whatever we have identified, whatever vetting process we have done as an organization, we are working with the software provider of that piece and making sure that it's getting fixed. And it becomes more and more critical with the open source software, because if an organization, you have an enterprise software for which you are paying something, that other organization is putting effort to make sure that it's secure. But if it's open source, then it's everyone's responsibility to make sure that we are looking at it. So in the first step, we have two parts to it. The first is looking at the software as we are selling it, making sure it's secure. Security is integrated in each phases of the CI/CD pipeline. The second part is whenever we are consuming a software, whenever we are a software consumer, we make sure that we are doing a vetting process, we are doing a due diligence on those softwares and making sure that we are working with the providers to fix it. Because if we do it collectively, it becomes a lot easier to look at the software, huge ecosystem we have as of today. Second step in this methodology is the implementation part. So our software provider can make the best secure software, but if we have not configured or implemented it correctly, it's still going to be an insecure product. And it could be as trivial as having the default setting disabled or secured, or it could be, do we have MFA enabled for all users, for all applications? And are we using up-to-date or non-vulnerable versions of plugins, actions, apps? There are different ways in which the software provider gives an opportunity to the consumer, to the user of the software, to expand the capability of the software. So in case of Jenkins, it will be plugins. I'm sure whoever has implemented or is working with the Jenkins will be aware about the plugins, which enables the user of the Jenkins to expand the capability of the Jenkins itself. Or in case of GitHub Actions, we have the apps or plugins where we are making sure that we are using the third-party software in that piece, making sure it's enabled. So for example, if anyone has used GitHub Action, they will be aware about the self-checkout action he's using. So consider a scenario where that action itself is vulnerable, which is getting used by almost all organization who is using action. It will impact throughout that way. So second piece is implementation and the configuration of that piece correctly. Third part of the methodology is we have done everything to make sure that we have a secure software, but being in a security domain for close to 15 years now, I know something bad can still happen. In that case, how do we make sure that we are responding and effectively and adequately to all the security incidents we are facing? Do we have the monitoring enabled? Do we have the logging enabled? Do we have the data to make sure that whenever something happens in terms of information security, we can do a root cause analysis of that effectively? So methodology will have three pieces. First is making sure that software is secure by default. Second is implementation securely. And then the third piece of that is making sure if something happens, we are ready for that. So now I'm going to introduce CICDGuard, which is built around the security pieces of that. First focus of CICDGuard is to make sure that we are handling the visibility problem, which I just explained, that security starts with the visibility, so visibility becomes key. How CICDGuard does it is, it makes sure that even the smallest piece of each CI/CD platform is breakdown in terms of graph, in terms of node. And then we have an edge representing the relationship between those different components. So CICDGuard is not just looking at the way, okay, this is the Jenkins server, this is the action. It's even breaking down that Jenkins instance into the number of jobs, which servers those jobs are using for running that particular job, what kind of plugins are getting used, what are the version of those plugins being used. So it will break down each component of CI/CD into multiple layers, and then each layer will represent a relationship to the other layer. Second piece of that is obviously the security part. After CI/CD collects all the information about the configured or the target environment, it identifies the security misconfiguration, security issues around those target environment, and then obviously provides the recommendation and the solution and the description, all of those details to the user of the software. Third thing, which in my opinion is the most critical piece, it tries to identify the relationship between the different platforms. So as of today, we have softwares, we have platforms which identifies the security issues to the specific components. But what CI/CD does, it also goes one step beyond that and makes sure that whatever environment we have configured as a user of the CI/CD guard, all of the interrelations are also identified by the software and providing the relationship towards that. So few examples, in a typical Jenkins job configuration, if there is a change in the GitHub repo, then that job will be triggered. So this relationship will also be captured into the CI/CD guard, which is a relationship between Jenkins as a DevOps or CI piece between the SCM, which is GitHub. It will also try to identify that how many version of the GitHub Actions you are using, what are their versions, do they have any known vulnerabilities, so on and so forth. And then what kind of users we have across the platforms, so on and so forth. These are just few examples I have listed. We'll know more about it once we go to the demo piece. This slide I just wanted to put from the FIA perspective, that how the database schema is defined. Like I said, it's not about looking at the component individually, it's about breaking down those components. For example, in case of GitHub, it will be breakdown on the basis of the repository, organization, user, team, so on and so forth. In case of, let's say, GitHub Action, it will be breakdown into workflow, how those workflows are defined as a jobs, what kind of steps are in those jobs, what kind of commands in running which in each step, what are the runners they are using, so on and so forth. So this is the architecture and workflow of CI/CD guard. So there are three main blocks of the platform. The first block is the scan engine itself, which is a collection of individual Python scripts specific to the target technology. So what I mean by that is, as of today, CI/CD guard supports four technologies: Jenkins, GitHub Action, GitHub, and JFrog. I have intentionally kept GitHub Action and GitHub as separate technologies because even though they are part of same organization, they serve very different purpose. So all of these are four Python script which you can use individually as well. You don't have to use the entire bunch of collection. You can use these individual scripts and just go about that. But if you use it as a whole, each scan engine will run against the target technology. And whenever you need to scan a particular technology, you need some kind of authentication. So in this case, it's a read-only access to the target environment. And there are two ways you can provide the authentication details, either by the environmental variable or in the command line itself, or you can store it in an input file and then go from there. Once you do all the scan, you have in the right-hand side the output format. You can store it into three ways. First is it will store into the Neo4j database. For those who are not aware, it's a database specifically designed to handle the graph-based kind of data. So it will be stored into the Neo4j database. You can have it in a JSON format and then store it and then redirect to the, let's say, your Sumo logic in which you want to scan. For example, if you are not interested in the web UI piece of it. And then it will obviously display in the terminal, which you can configure or use or reuse rather the way you want to. The third section of it is the analysis engine, which fetches the data from the Neo4j database. Once the scan is completed, it does two pieces. First is the analysis, the finding the security misconfiguration of the data stored in the database. And then second, it tries to identify the relationship of whatever technologies you have scanned. So practically how it will work is you will keep scanning individual technologies from using the individual scripts. Once you scan that, all of the data will be in the Neo4j database. As and when you are making sure that you have more and more data into the Neo4j, analysis engine will pick that data and make sure that analysis is happening. So all of these two processes will happen independently to each other. Analysis engine will keep fetching data from the Neo4j, do the analysis, and then store it. Scan engine you can run as and when you want it. And then I have a small web UI piece to just visualize the data, but you can use any parser of the Neo4j which can read the data from the database. So demo piece, I did a small hack. I recorded the session of recorded the demo. Trust me, it works when you directly run it from the GitHub as well. So like I said, all of the technologies are individual Python script. These are the four technologies supported as of today. In this demo, I'm running it against the GitHub action first. Whoever runs demo in the presentation will know that this could be the best time of having something in your presentation. So yeah, I was saying that for this demo, I'm running it against GitHub action first. For the authentication, I'm using environmental variable, because if I run in the command line, everybody will see it. So you can also run it with the command line, that's not a problem. So when you run the scan, as of now, it just processing data, it's storing everything. It's not doing anything as such in terms of finding vulnerabilities and all that. I have sanitized all the data just for the demo purposes. When you will run it against actual environment, instead of this square brackets, you will see the actual org name and repository name. So this is the output I was telling about you will have in JSON format in the command line. Don't worry about that. You don't have to store it anything. It is automatically storing into the Neo4j database. I just printed it from the demo purposes. It will just get printed. Second, I'm running an independent scan against the Jenkins server. So right now, it just have stored the GitHub action piece. Once I run the Jenkins scan, it will again store the data of the Jenkins into the Neo4j database. Like I said, in the architecture, once those two technologies have the data, analysis engine will trigger the analysis and will try to identify the relationship between these two. How it is doing is, because each relationship is represented in form of node, so it will try to identify, do we have any data of the existing node as well. So for example, I'm running Jenkins. Again, data is sanitized. I'm using command line, I'm using environmental variable for the authentication. Once that is run, it will keep going on. I did not fast forward it intentionally because I wanted to let you know how much time it actually takes into the environment. And it's a pretty big Jenkins testing environment I'm running against. So it's pretty fast in that technology because all of that is locally running. So as of now, what it is doing is it is processing all the jobs configured in the Jenkins. And then it is fetching the information about the job. It is fetching the information which servers that job is running. It is fetching the information which repositories those jobs are referencing. It is running the scan against the user, what kind of users are defined in the Jenkins, just to identify whether those users are mapping to other technologies as well. And then it will go for the plugins. it will go for all the pieces of that Jenkins and go from there. So the scanning time is directly proportional to how much configuration you have done to that target environment. So if you are using, let's say, 1,000 of scans, 1,000 of GitHub actions in your organization, then the scanning time will be different than, let's say, 100 actions, so on and so forth. So like this, I have run this scan database across multiple technologies. For the demo, I just demonstrated for 2 technologies. Once I'm able to run all the scan, this is how it's going to look like. Because I ran against a pretty big GitHub organization. I ran it against a pretty big Jenkins, I think 2 or 3 Jenkins servers, and then I ran it against 1 JFrog instances as well. So color code, it represents multiple things, as you can see in the node colors, like red will represent a vulnerable node, black will represent a GitHub, and then blue will represent a GitHub action, so on and so forth. Node is one piece of the component, and then the edge will represent the relationship between those 2 pieces. As you can see, even if I run it against just maybe 20 technologies, the data is going to be quite messy because I'm breaking down it to the multiple layers. So I have applied a what you can say, a filtering from the web UI. You can just apply the filters and go from there. So this is the filter for the Jenkins plugins. All the nodes are red, which means they are using the vulnerable version of the plugin one way or other. You can see all the details into the node when you click to it. You can apply multiple filters. For example, if you want to identify if you want to find the nodes which are plugins or build, it will try to identify that. One thing I wanted to highlight here is the relationship across technology. So as you can see, the black node represent in the bottom corner. In the bottom corner here, it represents a GitHub repository. And then this bluish color, it represents a Jenkins node, Jenkins build rather, which is the relationship I was talking about, that if there is a change in the repository, for example, if there is a merge request against the repository, then a certain Jenkins build is going to trigger. It's very difficult to do that analysis manually because you don't know how many repository configuration you have done. There is no backward relationship from Jenkins to GitHub. So that's what it tries to identify, that if your GitHub repository is vulnerable by some vulnerabilities, then it's eventually going to impact another Jenkins build. And let's consider a full scenario, which I don't have the demonstration here. Let's consider an overall scenario that you have a GitHub repositories, the configuration is something like this. If there is a merge request against the repository, a certain Jenkins build is going to it's going to put the artifactory into a, let's say, a JFrog artifactory. And then there is a configuration which is the CD part, that you have configured a CD environment, let's say Spinnaker, to pull that artifactory, pull that artifact, that binary, and put it into our testing environment. So if you scan all these technologies against the CICDGuard, it's going to build that path. It's going to build that path from your GitHub repository to your target, to your testing environment. That if you have a vulnerability in a certain repositories, which you might identify using this specific scanner. For example, if you're running a SAST scanner against a GitHub repository, then you will know from the CICDGuard that repository A is triggering building a Jenkins build B, which is putting the artifactory into JFrog artifactory, and then it is going to push into the testing environment. So as of today, we don't have any technology which can do that cross technology analysis and build the path. So for this demo, since I had access to only 2 technologies, I built the path using the 2 technologies. But if you do it for the multiple technologies, let's say you scan 3 technologies, it will build the relationship on those 3 technologies. If you scan n technologies, it's going to build path on that. So it has identified two cross-technology relationship, which will again give us an understanding of how that is going to work. So what's next? Like I said, the strength of CI/CD Guard is to do the cross technology analysis. For that, the support of technology has to grow. So I have listed few technologies. I am already working on few of them, which should be available in, let's say, coming months to support for two technologies. I'm working on drone and spinnaker. So more and more technology support we have, because every organization is using different technologies. So you might not use drone, you might use something else. And let's say you are not using GitHub as your SCM, you might use GitLab. So the more support CI/CD Guard have in terms of technology, the more data it is able to process and more relationship it will be able to build. The second part of that is the analysis engine, making sure that the relationship the CI/CD Guard is trying to identify, it's more and more mature, more and more robust, and more, within the technology itself. The one example I have put is like that, how the correlationship works between different repositories. So if I have to give an example, in a microservice architecture mode, multiple repositories can be responsible for building a particular service. So is there any way to identify that relationship, that this product line, this product service is getting built by these 5 repositories, so on and so forth. And visualization is the I'll say, because I am, as a developer, I'm not a front-end developer, I'm working on back-end more, but I'm trying to make it more intuitive, go from there. Yeah, that's all I had from my side. Thank you everyone for attending the session. It was really helpful. Code is open source, CI/CD Guard, just Google it, it should be available in GitHub. If you have any feedback, any question, comment, complaint, please feel free to reach out. I'm available in LinkedIn. Thank you so much. Have a good day. Thank you.
All right, thank you so much, Pramod.